Okay. Yes. I told you to read all the points, no, already. Yes, here is your objective material. Yes, students, see, atoms chapter. Now we are going to discuss objective points on this. Okay, so whenever it is required, I will explain all the points again. See, given question number 1, if K alpha radiation of molybdenum MO has a wavelength of 0.71 angstrom, then the wavelength of corresponding radiation of copper is what? So atomic number of molybdenum they have given 42 and copper we know it is 29. Okay. So see, from molybdenum one X-ray radiation is coming, that is K alpha. It comes out to be 0.71 angstrom. Okay. So from molybdenum the X-ray K alpha line coming out is 0.71 angstrom. When from copper, if it comes K alpha line, what will be its wavelength? Then what is the wavelength of this? They are asking. Yes. See here atomic number. See, atomic number is a very large value. No, there is 42 here, 29 here. So when we are dealing with the X-rays, we need to have one formula. That is a Moseley's law. So its statement is square root of its frequency is equal to some constant term into atomic number minus k square. Okay, here k is a screening constant, we can say. For k alpha, its value comes out to be 1. Means square root of frequency is equal to z minus 1. But they have given here wavelength. Wavelength values they have given. We know frequency is inversely proportional to wavelength. That means 1 by root f. Root f can be written as 1 by root lambda is equal to z minus 1, correct? Then what is 1 by lambda nana? Send root that side, it will become z minus 1 whole square. Yes, this is your relation you need to use. Okay nana, students? Yes, so I use that relation. See here what I am using, 1 by z is equal to 1 by lambda is equal to z minus 1 whole square. Okay, so first 1 by lambda of molybdenum they have given, it is 0.71 angstrom. Okay, then 1 by lambda of lambda of we need lambda of copper. Okay, lambda of copper, how much they are asking. Okay, so according to this relation, lambda of copper upon lambda of molybdenum can be written as, because it is inversely proportional na, z of molybdenum minus 1 whole square upon atomic number of copper minus 1 whole square. Okay, yes, wavelength of copper upon wavelength of molybdenum given 0.71. Okay, 0.71 angstrom is equal to, for molybdenum what is the z value? 42 minus 1 whole square upon, for copper it is 29 minus 1 whole square. Okay, yes, 42 minus 1 is 41. 41 square upon 28 square. So wavelength in copper you will get it as 41 square upon 28 square into 0.71 angstrom. So if you calculate this, you will get 1.52 angstrom. Do calculations, you will get the answer. PDF is not visible. Okay, one more time I will reinstall this. Now okay students, is it visible? Is it visible Nana? Okay then. See what I have given. According to Mosley law, 1 by lambda is equal to z minus 1 atomic number minus 1 whole square Nana. Right? Yes. So they are given lambda of molybdenum K alpha line of molybdenum is 0.71 angstrom. And K alpha line of copper we need to find. Okay. Lambda of copper upon lambda of molybdenum according to this formula it comes out to be Z molybdenum minus 1 whole square upon Z of copper minus 1 whole square. Clear? Yes. So lambda of copper divided by lambda of molybdenum 0.71 angstrom given 0.71 angstrom is equal to, this is given out to be 42, here they have given minus 1 whole square upon copper is Z 29, so 29 minus 1 whole square, so it is 41 square upon 28 square Nana. So K alpha line of copper will comes out to be 41 square by 28 square into 0.71 angstrom. Do this mathematical calculations, you will get 1.52 angstrom value. So option 2 is right answer. Clear students? Next, question number 2. In Coolidge tube, potential difference between cathode and anode is how much given? Potential difference given is equal to 120 kilovolts given. Okay. Then maximum energy of emitted X-rays. Energy of emitted X-rays is nothing but kinetic energy, and we know kinetic energy is nothing but electron volts. Means charge into potential difference. This kinetic energy. So charge into potential difference given is 120 into 120 kilovolts. It comes out to be 120 kilo electron volt. Okay. So option where it is not there in kilo electron volt, it is there in electron volts. Okay. Let us write 120 into kilo means 10 to the power of 3. No. Yes. Okay. So 10 to the power of 3 is not there. 1.2 is there. Yes. Convert 120 into 1.2, it will become 1.2 into 10 to the power of 2 is 120 into 10 to the power of 3 electron volt. So total comes out to be 1.2 into 10 to the power of 5 electron volt. Got it? So this is the energy of emitted X-rays when potential difference is 120 kilovolts. Got it? Small calculations. Option 1 is right answer. Okay students. Next, question number 3. If X-ray tube is working at 25 kilovolts, then minimum wavelength of X-rays will be, okay, voltage given Nana, how much? 25 kilovolts. Okay Nana? Yes. Then what is the minimum wavelength of X-rays? We know X-ray minimum wavelength formula is nothing but energy of incident radiation. Clear? Hc by lambda we can say. Energy is equal to hc by lambda. Are you understanding? Yes. Then lambda can be written as hc by energy of incident radiation. So in terms of calculation, if you keep h value 6.63 into 10 to the power of minus 34 joule second, c value 3 into 10 to the power of 8 meter per second, you need to do long calculations. So for that, a short formula, it is 12,400 electron volt upon energy in electron volt we should write, then you will get lambda value in angstroms. Okay, see options are all in angstroms only. Yes, okay. Let us find the lambda value in angstroms, so that we have to use 12,400 electron volt. But potential difference given 25 kilovolts, then how to find energy from this? Energy is equal to EV. Clear? Means 25 kilo electron volt. So 25 kilo electron means 25,000 electron volt. Okay, yes, substitute here. You will get lambda value in angstrom is equal to 12,400 electron volt upon 25,000 electron volt. Electron volt cancel, two zeros cancel, 124 upon 250. Okay, so this value comes out to be 20 Nearly 20, yes, 20 angstroms. Nearly you get 20. Do calculations. 124 by 250 means 12.4 by 25. Okay, na? Yeah, option 2 is right answer. Next. Question number 5. The structure of solid is studied by. How can we study structure of solids? By Bragg's equation, n lambda is equal to 2d sin theta. No, that equation is there in chemistry you have studied. So there what we will use? X-rays we will use. No? Yes. From X-ray uh, we can study the structure of solids. So X-rays is the right answer. We won't use gamma rays, cosmic rays and infrared rays. We will use only X-rays. Okay. Next question number 6. 50% of X-ray contains from Coolidge tube passes through 0.3 millimeter thick aluminum foil. If the potential difference between the target and cathode is increased, if you increase the potential difference, delta V if you increase, what happened to its energy? Energy of incident X-rays also increases. Okay, yeah. So if the potential difference between the target and cathode is increased, then the fraction of X-rays passes through the same foil will be, okay. How much X-rays will pass? First it is 50% it is there. Now if we increase the energy here, potential difference, more than 50% of X-rays can pass, because see, question is fraction of X-rays passing through the same foil. If you increase the potential difference, energy of incident radiation, that is nothing but X-rays will increase. When energy of X-rays increases, they can pass through thicker foils. They can pass if when their energy increases. Okay, so it comes out to be more than 50%, not 50%, not less than 50%, zero, however not. Okay, so more than 50% it is. If they'll ask, what happened to intensity of X-rays? If they'll ask about intensity of X-rays, then it remains same 50% only. Because intensities of X-rays doesn't depends upon potential difference we apply. It depends only upon the filament heat radiation in cathode tube. We will heat the filament so that electrons can produce. Okay. If more current if you pass through this, more heat energy will produce, and more heat energy means more number of electrons can eject out. Okay, this is different point. They're asking how many X-rays can pass through that thick foil. More than 50%, because their energy is increasing with increasing potential difference. Got it? Okay. Next question number 7. Let us go to question number 7. Question number 7. See, they have given when. See, it is important question, na? Logical question. See what they have asked. When 50 kilo electron volt energy of electrons are made incident on a target material, the wavelength of K alpha X-ray line was found to be 0.5 angstrom. So when the energy of X-rays is equal to how much? 50 kilo electron volt. When they falls on a target material, so when energy of electrons 50 kilo electron volt falls on a target material, X-rays of wavelength 0.5 angstroms are producing. Okay, now when the potential difference is increases to 100 kilovolt, when you increase the potential difference, what happened, Nana? Energy also increases, means energy of electrons increasing. Okay, then the question is, then wavelength of K alpha line from the same target. Wavelength of K alpha line from the same target. This is the target material. This target is same. Only the thing is they are increasing the potential difference for the electrons to accelerate. So when you increase the potential difference, energy of electrons will increase. Okay. However, when the energy of these electrons increases, what happened? This X-rays, what will happen? How they will produce K alpha line? K alpha, K beta, L alpha, L beta, they are called as characteristic X-rays, no? Did you remember? Characteristic X-rays they are. Okay. So how they will form? How they will produce characteristic X-rays? See here, a nucleus will be there. Around this nucleus, K shell, L shell, M shell, they will be there. No, here K, L, M, like this. Okay. So when electrons, when fast-moving electron, when they hit the electrons in the K shell, here one vacancy will be created. This vacancy will be filled by upper higher energy electron. So transition of electron will take place. Now when electron jump from higher energy level to lower energy level, to fill this vacancy, one radiation will produce. That radiation comes up to be X-ray radiation wavelength. Clear? Got it? Point understood? Now, whatever may be the energy of this incident electron, however, if we increase the energy or decrease the energy, they will create a vacancy only here. That means here they are asking K alpha line. In previous case also K alpha line, in this case also K alpha line only. K alpha line means electron is coming from second energy level to first energy level. One of the higher energy level to K shell, it is coming. So when this energy gap between these two is same, then wavelength of radiation also same, means wavelength remains same, 0.5 angstrom. It does not change. However, in Bohr's atomic model, it is different. See, in Bohr's atomic model, what we have studied, this is ground state. Its energy level is minus 13.6 electron volt, and first higher energy level, it is minus 3.4 electron volt, means minus 13.6 divided by n square energy formula. Clear? And third energy level minus 1.51 electron volt. So when electron jump from this n is equal to 3 to n is equal to 1 type of radiation, different wavelength will come. Whereas energy come from n is equal to 2 to n is equal to 1, then wavelength energy will be different. But whereas in this example, same K alpha line only they are saying. So this K alpha line wavelength will never change, because K alpha line in the sense it is coming from any one of the higher energy level to K shell. Alpha, that means from L shell to it is coming to K shell. This is called as K alpha line. So I hope you understand it very clearly while I have explained, and your chemistry sir also explained this. Okay, important point, you need to remember about X-rays. Okay. Yeah. So option 2 is right answer. Next. Question number 8. See question number 8. On increasing the filament current, here Coolidge extrude tube will be there here like this. Extrude tube will be there, and here one cathode will be there. Here one anode will be there. No, like this. Okay. And here one filament will be there, and here they will insert one filament, and through this filament they will allow current. Okay, if you increase the current through this filament, then what happens? Heat energy will produce. Due to that heat energy, emitted electrons intensity will increase. Intensity of electrons will increase. Are you understanding? Energy of electrons doesn't increase. Intensity, number of electrons emitting from this filament will increase. Clear? Got it? Yeah. So the question is, on increasing the filament current, X-ray tube, wavelength of X-rays increases. No, wrong, because there is no change in the energy of the electrons. Due to that, no change in the wavelength of X-rays. And penetration of X-rays increases. No, because energy is not changing. Intensity of X-rays decreases. Wrong, because when current increases means intensity of X-rays increases. Yes, option 4 is there. Intensities of X-rays increases. Yes, option 4 is right answer. Okay, conceptual question, you need to remember. Next, question number 9. Which of the following is not affected by electromagnetic field? Okay, alpha rays. Alpha rays means nothing but positive charge particles. Beta rays, nothing but electrons, negative charge particle. Cathode rays is nothing but electrons, negative rays. Okay. X-rays, these are not having any charge, so they will not be affected by electric and magnetic field. So option 3 is right answer. X-rays cannot be reflected by electric and magnetic field. The reason for that is X-rays are electromagnetic rays. Electromagnetic waves. Clear? They doesn't carry any electric field and magnetic field. So they cannot be deflected by electric field and magnetic field. X-rays is right answer. Whereas alpha rays, beta rays, cathode rays, they will be deflected by electric field and magnetic field. Okay? Clear? Next, question number 10. Minimum wavelength of X-ray is 2 angstrom. Then potential difference between anode and cathode is how much? What is the potential difference they are asking? When wavelength minimum wavelength is 2 angstrom. Okay. We know energy is equal to hc by lambda, or else it can be 12,400 by lambda in angstrom. Correct? You will get the value in electron volt. Yes. So energy is equal to 12,400 upon lambda value given is 2 angstrom. Yes, 2 in electron volt. So it comes up to be how much? 62 to 124. No, yes, 6,200 electron volt. This is the energy. But what they are asking, potential difference. The energy we can write it as EV0. Potential difference is equal to 6,200 electron volt. So electron cancel. We will get potential difference is 6,200 volt. Yeah. So option is given in kilovolts. So how can we write this? 6.2 into 10 to the power of 3 volts. No? Yes. Means 6.2 kilovolts. Yes. This is the potential difference. Option 2 is right answer. Got it, students? Okay, na? Next. Question number 11. See here. Question number 11. X-rays obtained by Curie tube are. What type of X-rays they are? Okay. See, continuous X-ray spectrum, if we observe carefully, here wavelength will be there in angstrom, and here intensity of X-ray spectrum will be there. So this X-ray spectrum, it is like this. Continuous X-ray spectrum I am showing. Means here wavelength lambda minimum wavelength will be there. Means the X-rays which are producing from a target material will be having one particular minimum wavelength. Less than that wavelength, there is no X-rays. Are you understanding? So there will be one certain minimum wavelength will be there for the X-rays. More than that wavelength only, all the X-rays will be present. Okay? So if the wavelengths are different wavelengths are there, then how can we say them as a monochromatic? Monochromatic means same frequency, same wavelength. First option they are given monochromatic, so wrong. X-rays obtained by Coolidge tube are monochromatic, wrong, because they will be having different wavelength range. Okay. Next option 2, of all the wavelengths below the maximum wavelength. Maximum wavelength will be infinity nano for X-rays. Minimum wavelength will be certain value will be there. So below of all the wavelength, below a maximum wavelength. So it is wrong option. It is not giving a clear information about the wavelength of X-rays. Of all the wavelength above minimum wavelength, yes. From above the minimum wavelength, all the wavelengths are there. Yes, this is the right answer. Of all the wavelength between maximum and minimum wavelength, so wrong. This is the right answer. Of all the wavelength above the minimum wavelength, X-rays will produce. This point is important. You need to remember. Okay, students. Next, question number 12. X-ray in an electromagnetic radiation. X-ray is an electromagnetic radiation. So X-ray photons carry, because it is electromagnetic radiation, they neither carry electric charge nor magnetic movement, we can say. So photons carry electric charge, wrong. Magnetic moment wrong. Both electric and magnetic moment, no, they doesn't carry. Yes, option 4 they have given. They neither carry electric charge nor magnetic moment. Option 4 is right answer. Okay, next. Thirteenth question. Question number 13. Characteristic X-rays are not obtained in the spectrum of hydrogen atom because what is the reason why we will not get characteristic X-ray spectrum? See here, X-ray spectrum, if we will observe carefully, this started from one minimum wavelength and up to infinity, and its curve is like this. One peak values will get somewhere, yes, here like this. Okay, these peaks are called as characteristic X-rays. These peaks are called as characteristic X-rays. This is K beta line, this is K alpha line, this is L beta line, this is L alpha line. We need to remember this. First we will get K beta line only. Later we will get L beta. Remember this. Okay. But in hydrogen spectrum, we will get only continuous spectrum. Only continuous we will get. Continuous spectrum we will get in hydrogen. What is the reason for that? The reason for that is the energy level difference. Energy level, see here, minus 13.6 electron volt, whereas second orbit n is equal to 2, minus 3.4 electron volt. Next it is minus 1.51 electron volt, n is equal to 3. N is equal to 4 if you take, it is minus 0.38 electron volt, like this. This energy level difference is very small in hydrogen atom. This is the reason why we will not get a characteristic X-rays here. These peak lines will not get in hydrogen spectrum. Reason for that is the energy level difference here is very less. Whereas if you take a higher atomic number energy levels, we know energy is equal to minus 13.6 Z square by n square. No, yes, higher atomic number also we need to multiply. It means energy level difference will increase in terms of square of its atomic number. Got it, students? Yeah, option 3C. Energy difference in energy levels of hydrogen is much less. This is the reason why we will not get a characteristic X-ray spectrum in hydrogen. Clear? So 13th question, option 3 is right answer. Next, question number 14. Which of the following is related with the characteristic emission of X-rays? Okay. Yes. Alpha particle emission, no, it is a decay, radiation. Nuclear reactions, we have studied this. Electron emission, it is also beta decay, we can say. Positron is beta plus decay, we can say. K electron capturing, yes, it is related to X-rays. Alpha emission, electron emission, positron emission, these are the nuclear reactions now. Nuclear reactions. Decay loss means a parent nucleus, something like XZA, due to that alpha decay it will become daughter nuclei Z minus 2, A minus 4 plus alpha particle, like this. This is nuclear reactions. This alpha particle emission, beta particle emission, positron emission. These are three nuclear reactions. Whereas K electron capturing comes under X-rays. What is the meaning of K electron capturing? See here nucleus will be there. Yes. Let's imagine this is the nucleus, and around this nucleus, what will happen? Yes, electrons are orbiting. No, in K shell, L shell, M shell, N shell, like this. Okay, this is N shell, imagine. Okay. This is the nucleus, K shell, L, M, like this. KLM. Okay, so let us imagine here electrons are there, some electrons will be here like this. Okay, so in express what happened, fast moving electrons they will come and they will hit this target element. Due to this electron will be a vacancy will be created, one small hole will create here, we can say. Okay, now this hole will be filled by the electron in the higher energy level like this, so it will capture this electron, this we call it as K capturing. Okay, so due to this a radiation will emit, that radiation wavelength comes under X-ray radiation. Okay, clear? Next, 15th one. Penetration power of X-rays depends upon. See, penetration power means they have to penetrate through like thick walls, we can say. So when they X-rays can penetrate through these thick walls, when their energy increases, how can we increase the energy? We can increase the energy by increasing the potential difference. Are you understanding? Yes. So penetration power of X-rays depends upon applied potential difference. It doesn't depends upon the nature of the target, not depends upon the current flowing through the filament. Current flowing through the filament increases, number of photoelectrons we can say, or number of electrons from that filament will increase. But energy of that electrons does not increase with increasing potential difference. Okay, so penetration power of X-rays depends upon potential difference that we will apply. Okay, Anna? Next, which of the following have the velocity equal to? So we know that electromagnetic rays will travel with velocity of light. What are electromagnetic waves? X-rays or electromagnetic waves? No. Radio waves, microwaves, visible, UV, X-rays, gamma rays, these are electromagnetic rays. These all rays will travel with the same velocity, that is velocity of light. Whereas cathode rays, anode rays, positive rays, we can't say that they are traveling with the velocity of light. They doesn't travel with velocity of light. Okay? Yes, option 3 is right answer. Next. Question number 17. See question number 17. The energy of characteristic X-ray photon obtained from Coolidge tube comes from. So how this energy of X-rays will be there? Okay. So energy we can obtain from potential difference. See, kinetic energy of incident radiation. No. Kinetic energy of free electrons from a target element. No, wrong. Kinetic energy of ions of a target material. Wrong. Electron transition in target material. Yes. So in target material, electron will get transition from higher energy level to lower energy level. Due to that, X-rays will produce. This X-rays, energy of this X-rays depends upon this energy transition, electron transition, from which orbit to which shell it is moving. Depending upon this energy level difference of this shells only, energy of X-rays depends. Okay? Yeah. So it depends upon the electron transition in electron material, target material. Option 4 is right answer. Okay, clear? Next, absorption of X-ray is maximum in which of the following sheets? They are given copper, gold, beryllium and lead. Yes, lead is right answer. Remaining 4, copper, gold, beryllium, these X-rays they cannot pass more among these gold, copper and beryllium. Because reason C, we can say Mosler's law, what we can say frequency are 1 by lambda. Lambda is equal to z minus 1 whole square. No? Yes. If this z value is more, wavelength will be less. Clear? So they can penetrate maximum through lead, we can say. Next, question number 19. In X-ray spectrum, wavelength lambda of K alpha depends on atomic number as. Yes, directly it is lambda depends upon atomic number, like lambda is equal to 1 by z minus 1 square. So just now written frequency is proportional to z minus 1 whole square. And then it can be written as 1 by lambda is proportional to z minus 1 whole square. Then lambda is proportional to 1 by z minus 1 whole square. Clear? Yes, this is Moseley's law. Option 4 is right answer. Next, if potential difference applied to a X-ray tube is V volt, then minimum wavelength of X-ray produced will be, minimum wavelength of X-rays produced in angstrom will be nothing but 12,400 upon energy electron volt. Okay, yeah. So because they are not, these are not electrons, these are X-rays. So option 4 is right answer. This is for only for electrons. 12.27 by root V. This is only for electrons. This is only for electrons. Okay. So 12,400 by V we can say. Because see here, angstrom they have given. Due to that 12,400. If they give here nanometers, it will be 1240. This option will come. Clear? Option 2 is right answer. Next, 21. Are you understanding, students? 21 question. The minimum wavelength of X-rays produced by electrons accelerated by a potential difference of V volts is, we know energy E is equal to h nu. Okay? Clear? Or it can be written as hc by lambda. Then lambda is equal to hc by E. And we know E is nothing but electron volt. Yes, hc by eV is the answer. Yes, option 3 is there. hc by eV. Got it? Next, in electromagnetic waves spectrum, X-ray region lies between. We know I have given one code for remember me, I am very useful, extraordinary guy. So X-rays lies between gamma rays and UV rays. Okay, so gamma and ultraviolet region. These X-rays are lying between gamma rays and UV region. Yes, this type of questions are important. You need to remember. Easy questions these are. You need to remember. Okay. Next, if V be the accelerated voltage, then maximum frequency of continuous X-ray spectrum. Here I only see maximum frequency. We can say right here. We can write here frequency U is equal to h by E. That is nothing but h by EV. We can write. Okay. Yes. H by EV. Yes. Option 4 is there. Option 4 is right answer. Are you understanding? These are formula based questions. You need to remember these all. Okay. Next, question number 24. See what they have given. The shortest wavelength emitted from X-rays tube depends upon voltage applied to the tube, nature of the gas in the tube, current in the tube, nature of the target material. Yes, voltage applied to the tube. Option 1 is right answer. Just now I have given the formula that what wavelength lambda is equal to hc by ev. This wavelength depends upon the voltage applied. Next, in X-ray tube, intensity of emitted X-ray beam is increased by. How can we increase the intensity? By increasing the current in the filament. Increasing the current in the filament. First option only right answer. You need to read these theory points then you can answer them easily. Okay, students, understanding now? Next,